Okay, hello everyone. In this video we are going to go through some differentiation and continuity problems from calculus, and here is the first question. It says the figure above shows the graph of a function f which has a vertical tangent at x equals 2 and a horizontal tangent at x equals 4. Which of the following statements is false? So just here we need to find out which of the statements is false, so that will be the answer. So let us go one by one, so from A to D. The first one says f is not differentiable, so I will just use the highlighter. F is not differentiable at x. So f is not differentiable at x equals -1. Well, this is correct. So because the graph of f, this is correct. So this is not false statement. So it's a true statement. So A is not an answer. B, it says f is not differentiable at x equals 2 because the graph of f has a vertical tangent at x equals 2. Well, you can see here in the task it is given which has a vertical tangent at x equals 2. When it has a vertical tangent, then it's not differentiable. So this is also correct. So this is not the answer. It says f is not differentiable at x equals 4. Remember, we are looking a statement which is false. We need out of these a statement which is false. That will be the answer. So we are always asking, is the statement given false? So f is not differentiable at x equals 4. So that's here. That's here. You can see there is a horizontal tangent. That's something like this, and then something like that. So this is horizontal tangent. Because the graph has a horizontal, no, this is wrong. So, or false. So this is one option that suits the requirement that it is a false statement. And it says f is not differentiable at x equals 6. So f is not differentiable at x equals 6. If you look at equals 6, here it is not continuous. It has a removable discontinuity, but it is not continuous, therefore not differentiable. So this is a true statement. So the only answer is C. That is the only false statement. All other statements are correct. So this is true statement. So that is question 1. Okay. Next question. It says, which of the following statements about the function f which of the following statement about f, if true, cannot be used to conclude that f is defined at x equals 1. So we need to figure out when from A to B we can conclude that f of 1 is basically defined, or f of 1 can be evaluated. So you can pause the video and try, And here is the answer. So we need a statement that cannot be used. So here the word is this, that statement cannot be used to know f of 1. Now if let us say the first option is a limit f of x when x approaches a exists. So does this imply that f of 1 can be computed? The answer is no. So here, no. If you take f of x equals x minus 1, for example, x minus 1 cubed over x minus 1. This function is not defined for x equals 1, so f of 1 can't be evaluated. But limit exists. So limit when x approaches 1, f of x is, you can write this as x minus 1 and x minus, then x minus 1. Now under the assumption that x is different from 1, you can cancel, and that is x minus 1 squared. So that limit is 0. So the limit exists, but f of 1 cannot be evaluated. That's important to see. So f of 1 can't be evaluated, but limit exists. So we cannot use the fact that limit exists that to find the value or at that point. Let us see b. F is continuous at x. This can be used because it has to be defined at 1. F is differentiable. Yes, because differentiability implies continuity. And now you can use b. The line tangent to the graph x equals 1 exists. Yes, because this is the same as c. And then based on b, you can use that, saying, well, it has to be continuous, therefore f of 1 is defined. So the final answer is we cannot use a. So this, which of the following statements, statement A can't be used. Others can be used to find that f is defined at x equals 1. So that's that question. Next question. Says let f be the function defined above, so x squared minus 20 for x strictly less than 5, minus x squared plus 20 for x greater than or equal 5. One of the things that you can do, you can pause the video and graph this function if it's easier for you, but let us see. So which of the following statements is true? So there is only one statement. If you look at the question, we need to find which of the following is true. So if you want always to help yourself a bit, read the question carefully. Which of the following statements is true? F is not differentiable at x equals 5 because f is not continuous at x equals 5. Let us see if f is continuous. Is f continuous at equals 5? So limit when x approaches 5 from right, f of x is limit when x approaches 5 from right, that is x squared minus 20, which is 25 minus 20, which is 5. And limit when x approaches 5 from left, f of x is limit when x approaches 5 minus x squared plus 20, which is minus 25 plus 20, which is minus 5. And these are not equal, so f is not continuous. Since it is not continuous, so not continuous, therefore not differentiable at 5. So the A is actually correct. Since we are looking for only one statement, you can just go and say, okay, I have solved this problem, or we can go through it. F is not differentiable at x equals 5 because the graph has a sharp corner at x equals 5. Well, it doesn't have a sharp corner, it has a jump. No, it has a jump. So this is not correct. F is not differentiable, it has vertical tangent. No, it doesn't have vertical tangent. It doesn't have tangent at all because it is not differentiable. And f is not differentiable because it is not defined at x. Well, it is defined. F of 5 is minus 5. If you look here, so f of 5 is minus 25 plus 20, which is minus 5. So it is defined, so this is not correct. So the only correct answer is A. So f is not differentiable because it is not continuous. Okay, this is the same question that we solved above, and this is also the same question, and let's see this one. The figure above shows the graph of the function which has a vertical tangent at x equals 4 and horizontal tangent at x equals 5. Which of the following statements is false? So which of these is false? Let us see. So we need to find a false statement. That is the trick. F is not differentiable because, so this is true. Okay, sorry. This is true. F is not differentiable because the graph has a jump. You can see at 2, it has a jump. So this is correct. So that's true. F is not differentiable at 4 because the graph has vertical tangent at 4. So if you look, there is a vertical tangent here. So this is true. When it has so vertical tangent, that means not differentiable. Why in that case f prime or at that point is actually infinity. F is not differentiable at x equals 5 because it has a horizontal tangent. So that is what is given here. It has horizontal tangent at x equals 5. Well, this is false. So this is false. Because if a function has horizontal tangent, then it is differentiable. And they are saying it's not differentiable. This is wrong.